We're back to another Jocademy BC day. Day 4, but it's really the same day. Well, today we'll be learning about polar coordinates. Or polar graphs. So, reason why I made this in the same day is because polar and parametric have some similarities with each other that make it, it makes it, So, what you do first is skibbity toilet. Alright, so what is polar? Polar. Well, actually I just show it on Desmos. What the hell is this song? Oh, this is my beat. So polar is this, where instead of a grid Cartesian plane, you got a polar plane, where every circle or every square is turned into a circle of that one box turned into a square with radius 1, and so on and so forth. I mean, you can still graph normally on this, but you know. So basically, polar coordinates are defined as r theta, just like how there's cos theta and there's x, y as their coordinate. R theta, where r is the distance away from the radius of a circle, and theta is literally an angle of your radius length. So if a radius was 1 and I had an angle of 45, I would do this. If it was 215, I would get 15 degrees, which is around here, and then I would write all the way to 2.
Yeah.
Okay.
Couch potato, it's great.
I'm a Pluto
15
TV couch potato.
Pluto TV makes
degrees, and wherever that ends is your coordinate for that.
So what do you like to watch?
So basically, r equals
I love the Real Housewives.
x squared plus y squared via the Pythagoras theorem, right? And this angle is this thing.
It's like
So yeah,
winning the lottery, but with
so you have a
your eyes.
radius x squared plus y squared given that to translate this system to this, to get from here to here, okay, x equals r cosine theta and y r sine theta. So when you square them, you get like Pythagoras. X squared plus y squared, r squared cosine squared plus y squared, so that just be 1 times r squared. And you can see in the graph, if I had a graph of the unit circle like this, the unit circle, if I had a point here, say like here, the radius r, and we'd have this with cosine theta and sin theta, and adding them would equal 1, but that would, because 1 originally is r. But if we make r not 1 but an actual changing function, like if we made this r a changing function, a function that changes, like remember how I talked about in paramedic, if you watched it, that x of t and y of t are their own functions for their own claims. Like if my x coordinate was changing by x squared, or actually it would be t squared, and my y coordinate was changing by like sine t. Now your t, if you like drew it on a graph, what do I do? Right, let's just go over here. So t squared sin t, where the graph of y, the y value would be changing like this, you know? Yeah, it's got it. Like that. So on the y coordinate of y t x of t, where this is t and this is y of t, it would be changing. The y value would be increasing up to a point, and it'll slowly slow down and then go back up. And t squared, the graph of t squared, or x of t, is a parabola, so it would be increasing the more you go. So it would look something like this is actually hard to visualize. Actually no, it would like go like this and then go backwards or something like that. Let's just graph it. Let's see. T squared sin t. Okay. Oh, never mind. Wait, yes, something like that. Yes. So, honestly, thought it was gonna go back on itself, but no, it didn't. Actually, no, never mind. It did go back on itself. So if we had n equals 1. Look at that. How it went backwards on itself right there. Look at that. Look at that slowdown. You see that slowdown? You guys see that slowdown? Like I was talking about earlier? And we just put this as 100 negative 100 and t equals 1. Look at that. Look at that slowdown. You see that slowdown? And it went back up. And this is decreased at the same rate. So, and that's what I was talking about. Anyways, this is not a video about paramedics. So let me just reverse all that. Back to what I was saying. Just like how paramedic is like that. Polar function has an r, a radius that isn't always staying at 1. Like in here, like if I like also r equals theta, it's not r equals x. So r equals, when did I draw a circle? Oh, 1. Yeah, if I kept r constant, you know, y equals 1 would look like that, r equals 1 would look like this, where if I drew a r in here, oh my bad, n and n minus 1. Look at how, wait, no, that's not how I meant to do it. I don't want that, I want r to change. Though, what did I put? N. Okay, I don't know why r is changing. Let's just have this as Oi, oi, oi. Baka. This is not what I wanted. Hold on. I just realized, guys. No matter what time it is, it will always be 1, as in y equals 1 is a constant no matter where I put n. It's always gonna be like that. Just like how, yeah, so my bad, guys. So let's get a better example, theta, where it's a representation of y equals x on a circular plane, where if I actually put n in here this time, you can, I don't know. Look at it. Whoa, you can see it drawing. Look at that. Look at that. You can actually see it growing now. And if I had it like that, you can probably see the circles a lot better. But it's just better if I had it like that. Look at that. Keep it at 0 or less than 0. Look at that. Yes. And it makes sense, like y equals, remember, okay, so our radius is theta, right? And we have an angle, so we would, like I said earlier, I don't know, that you would translate the radius from the origin and the angle to find certain points. So if we start at 0, 0 at an angle of 0, and then if we went to like point 1, 1 is 1, radius 1 at 45 degrees. So 45 degrees at a length of 1 would be like right here, or something like that. Wait, let's draw this. How do I draw a line that looks like that? Dub dub dub, yes yes, skibbity dubbity dee dee, skibbity dub dub, skibbity, 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 dub dub dub, yes yes, skibbity dubbity dee dee.
Weeknight meal,
Alright,
to eat
guys.
soup, and whole roasted chicken,
So,
all
look,
in one easy trip. Find out
as
what's on sale in
y
our weekly app.
expands,
Shop the deals
the
online
angle
or in
is
store.
always
Sincerely
45.
Food. Sincerely,
Angle.
Albertsons.
Wait, no, hold on. Oh my god, guys. So this is a little bit better. It's easier to explain on a trigonomic function. Try to explain it through these means. So the angle is given through the x value of the Cartesian plane, aka the 1x1 squares, and the length of r is given by the y coordinate. So at here it would be what is 1? Right, so 1 degrees, or what is 1 in radian? 1 rad at 1 distance something at a radius 1, so 1 rad is like 56, so it'd be like 56, 1, it'd point up around here, and then at 0 it's radian 0 at 0.0, so that's no angle at 0. And then let's go to 0.45. As you can see, 45 degrees at a distance of 0.45. Bang. Okay, let me just explain this better with an actual function, cosine theta. Let's do cosine 2 theta, where cosine 2x is graphed. So, like I said earlier, 0, 1, and believe it or not, there's a starting point of where you start drawing these graphs. So at 0, 1, so that would mean that there's a radius 1 at an angle of 0. Where do we see that? It's right here, and we can prove that with the end thingy. Look at this, it starts from, look at that. Look at that, it starts from 1. Look at that, it starts from 1. And then when we see here, pi over 4 is 0. So that means it is a 45-degree angle with a radius of 0, so it should be at the origin because it's radius 0, and the x values are the distance away from the origin. So there's 0 distance away from the origin in this case. So look at that. So it hits this at 0, 0, signifying that the egg at the time that it hits here, it's 0, 0. Note that the graph values of y isn't exactly the values of the angle, but rather, earlier as I said, x equals r cosine theta and r sine theta. That's where you're actually getting your y values from. So remember that. Because if I put in y equals r is cosine 2 theta, right? Times, or 2x times cosine x, x equals, wait, oops, let's keep it right now. Actually, I'll just keep it as from t, h, to h, I'll make this h. Oh wait, oopsies, sin h. No. Wait, what the hell? Look at that, it follows the line of the thing now. It fully traces the thing. So the y and x values are based on cosine 2h. Like you can, if I put this into a parametric equation, like this, t, cosine 2t sin t, you get the same equation as I showed you earlier. And I put this as n. Look at that. It grows just the same as the purple function right here. So yeah. So you could easily write this as a parametric function given x equals 2 cosine r, x equals r cosine h, and y equals cosine r sin h. So yeah. And these look at that. Many applications for these type of functions. And again, I was telling you how to graph these. As you can see, around 2 pi, these graphs, cyclic functions that are bounded by intervals or ranges, like sine and cosine, always end off at 2 pi. But functions like I showed you earlier, r equals theta, since there is no bounded cyclic function of y equals x or r equals theta, it's gonna go on for infinite. So yeah. And so I'm gonna show you again how do you draw these. So this is the origin. It's the origin. And now it's negative. It always goes counterclockwise too. So now we have negative radius, or just the opposite side of the radius. As shown here, there's no negative side for the circular grid. We have negative or slash the other side of the radius. And the next time next thing is -1, so it's gonna hit, I think, here, or actually maybe here, at pi over 2, so at 90 degrees. It's probably here at 90 degrees, because it's a sine function, a cosine function, so it should hit here, right? Yep. So since pi over 2 is 0 for this function, it will have 0 degrees, -1, or 90 degrees, -1. Like that. You like pancakes? Yeah, we like pancakes. Oh, and also the degrees is based off the unit circle as showed by as here, not by the function here. So 90 degrees should still be 90 degrees like that. But since it's counterclockwise, it should, I bet since the radius is negative, it's gonna go this way. And so the next part should be when I finish the loop and I go back here. Finish the loop, I go back here at 3 pi over 4. So let's see, 3 pi over 4. Wow, it does do that. Ooh. And since there's a 0 radius. And then we see here, pi 1, that means since it's positive, this side is gonna hit this side. So negative means going down and up. Positive could just mean either here or here, but based on the angle, it'll go here or here. Alright? So we go to pi, that does hit. Now I should just go back to Cartesian. And 5 pi over 4, so it's gonna hit here again. 5 pi over 4 should hit the origin again. And I think you get the point. It's gonna go up. The next one's gonna be negative, so you know it's gonna go
families with glee,
here, and then it's gonna come back down, and it's gonna go back here to finish at 2 pi. Even though that every period of the cosine function is gonna be a pi, this function will still finish at 2 pi. Like I said earlier, it follows the unit circle, but still at pi it's half the function, so at least that's something. But also to remember, cosine pi or just sine pi will just make a circle. I hope you know why. Just look at it. One,
is so important during times like these.
One, and this is pi over 2, because pi over 2 is 0,
Light some candles, put on some
and then
soothing music,
pi
and
-1.
Your puppy is none of those in
Whoa, stop cursing at me.
On business. Voting
Pi
is
-1.
self-care. Check in with yourself. Check your
-1.
registration. Check
Wait,
your
hold
voting
on.
plan. Visit rockthevote.org.
Oh. Oh no. Okay, my bad guys. The circle, it completes a circle at pi because it, like, I don't know how to explain it, but it just does. Okay guys, it finishes at pi. It hits 0 and it'll come back for another one. Dun dun dun. Because pi is angle is that way, but I don't even know why it comes back like that. Oh well, that's just too bad. Dun 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 dun. That's basically beginner stuff to polar. No, no derivatives and integrals yet. But I will say the reason why I linked it to paramedics is because you have to turn it to paramedic and then find a derivative like that. That's how you find derivative of these functions. So yeah.